So now we have one more talk by Daniel Luca from ETH Block, and we would like to say a very special thank you to him as he's been supporting ETH Bucharest, and I would like you to welcome him right now. Woo!
Okay, so here I am again. Good. Okay, so the slides. Could I also see the slides here? So today I want to talk about this concept of Doppelganger networks. I saw this happening in the wild, and this gave me the idea that there could be a new category of networks, a new category of applications, and I wanted to make this more known to people, so there maybe more of this will happen. Okay, so I'm going to cover the introduction to Doppelganger networks. That means like what they are, how you can build one, what's a good example and how this kind of got started. There are some clear advantages, but there are some very, very bad disadvantages. I still think there's a lot of untapped potential that we can probably solve, or people can take this idea and put it forward. So I'm Daniel Luca. I kind of presented myself. Yeah, I'm a developer at heart. I did a lot of security in blockchain. I was with Consensus. I was with Consensus Diligence, where I did security. I also founded my own security company. I created my own stablecoin. So I kind of did a lot of things. But now I work with ETH Block, which is a crypto VC. We like to invest in infrastructure projects, but we can look at everything. Everything is very important to us. So a Doppelganger network has two properties. It mimics a network. It can mimic an EVM node, like the Ethereum network, but it changes the rules. So that means that in order to mimic it, you replay the transactions on your local fork, but then you are changing the rules, so it makes it incompatible, and you can do a lot of interesting things with it. I think it's much simpler if I give you an example and we walk through this. So let's say that you have this very, very simple contract, and you're trying to do the simplest for your users to achieve something. And in this case, you're just calling the deposit function. You want users to allow you to allow themselves to deposit some kind of ether, and you need to track that for each user. And this is probably the simplest thing, but it doesn't help the developers, it doesn't help the UI, it doesn't help a lot of people because you don't have analytics, you're not tracking a lot of things, you're not adding a lot of functionality to it. So what you can do is that you have these 11 lines of code, and then if you replay all of the transactions and you replay them to your Doppelganger network, you can do something very interesting. You can change the rules so you allow for code mutability. So now you can deploy new code for the same contract. You add a new event. You start tracking like who deposited, when it was deposited, what was the block, what's the total number of deposits. You add all of that functionality, you emit the contract, you accumulate the deposits into one variable, maybe you add more, you emit those events, and the important thing to understand is that the user interacts with the contract on the left, but the developers interact with the contract on the right. The advantage is that it's very cheap for the user, and the devs can update the code, fix some kind of analytics if they want to add more, if they want to fix something. They can also backtrack and replay all of the transactions again. And it's much more expensive to run the contract on the right, but it doesn't affect the user. And the expensive part is something that we think about a lot when we're developing contracts, because then we're putting a lot of pressure on the users. So in order to do that, you kind of fork the chain, or you fork the state. You update the rules. That means you have to update the software that runs that. It could be a Geth, or it could be something more modular like Reth. You replace the smart contract code, and then you start tracking the events. And all of those events are useful because you can now display analytics in your UI. You can tell users a lot more. But again, they're not paying for all of that computation. They don't need it. You need it. So this idea started with Shadow.xyz. In December last year, they said, OK, we just raised $9 million. It's led by Paradigm. And we're going to do free logs for everyone, free logs for your contracts. And this is how we're going to do it. So in order to understand the advantages, you could add advanced analytics. It's cheap events or free events for users, is cheap events or low-cost events for devs. And it's also interesting that there's a low context switch. Previously, you had to write some kind of JavaScript code or TypeScript to add that analytics on top. And you as a developer, then you could start understanding what's going on. But now you can use the same developer that wrote the original Solidity contract and add more functionality to it, and there's no context switch. And developers understand that this is an important thing, and it does increase productivity. If you use Shadow, it's a very easy setup, because then you don't need to do all of those steps yourself. They do it for you. You just click a few buttons, and then you replace the code, and then there you have it. There's also, it allows you for code mutability because you can update the code. You can add new events, and they will just retrack all of the, redo all of the transactions, and you have more data now. But there's a big part, which is all of the disadvantages. The thing is, we're kind of, we do like decentralization, and we kind of have a gag reflex when we heard things are centralized. And Shadow is very, very centralized, and for some very good reasons. But the problem is that now you have multiple sources of truth. Some people know that when front-end development was kind of picking up, we would have all those input elements, the buttons, and so on, and we had all of that state in each of the parts. And Redux came along and said, no, we're going to have like a huge structure, and we're going to dissipate all of that state to the events, but the real source of truth is unique, and it's in one place. So that's exactly what they did, and then we were able to see more single-page apps, and this front-end revolution kind of started. It started with Redux, but it helped Vue, it helped React, it helped Angular. Everybody kind of started to adopt this concept. In blockchain, it's a bit different. So let's say that you're trying to track something, but then because it's a private fork chain, it's a private version of my truth, I may interpret that data one way, but others have to also do the same computation themselves. So they may have very different outcomes. So when they try to interact with you, because everything is a Lego piece, they might think that things are one way, but they're actually in a very, very different way. There's also the possibility of manipulation. Because it's centralized, Shadow could manipulate the data. You might not even know it. You should probably have to do the computation again yourself, but there's this big risk. And it may not be robust. They could go down, or they could say, our servers don't work, and cut you off, and then your app doesn't work anymore. Server issues. So we still have this idea of doppelganger. Like, there's still a lot of possibility, and I kind of want to present how you can think of it in a different way. So let's say that this doppelganger includes the EVM node, or includes Ethereum. So everything that happens on Ethereum happens on your network. You don't need a bridge because you're replicating all of the transactions. And you trust them because they were cryptographically signed. But what can you do on top of that? You can add compute. So this could be, let's say that one user does something on Ethereum, and they signal on your doppelganger that more compute needs to be done. So this could be something like AI, more like inference, or some kind of training, or some kind of compute that you want to add, and you trust that user because they did the transaction on Ethereum, and it just signaled on your doppelganger that you have to do it. You could do more storage. So you could store a profile picture, you could store an image, you could replace something, you could delete something, and then you just make your doppelganger serve that specific need. And I think there's lots of other possibilities, and we kind of have to explore that. And I see this doppelganger like a weird L2 without a bridge, which is still connected to Ethereum, but it's one way. And if you really want to, you can still create a bridge and push data to Ethereum. And this is, I think, a novel concept and a new way to think about this. But also, over time, we were able to create applications permissionlessly. You didn't need to ask Ethereum to accept your application. You would just deploy your smart contracts, and it would run there. But what if you want to add a specific cryptography scheme? What if you want to have bigger blobs, or to be saved for a longer period of time? You can add this functionality, still be very tightly connected to Ethereum, but you don't have to ask the permission of the Ethereum larger community. And I think that's very interesting. It would still make sense to create a network out of it, because up until now, I kind of talked to you about only the doppelganger part, but not the network part. So you can create a new type of transaction that runs on your doppelganger. It uses all of the Ethereum read state and works with that. So I think there's a lot of possibility there, and things are underexplored at the moment. Okay. So I understood there would be questions. I'm not sure if we can do that, but I'm free afterwards. This is my Twitter. Can we do questions or not? Okay. Okay.
What could I build on your Doppelganger network that would not be possible elsewhere or on the main chain?
So you can change Ethereum's rules. You can add precompiles with specific cryptography schemes that are not part of Ethereum now. You can store more data. You can do GPU computation. And I didn't create this doppelganger, it's just a concept. So I'm trying to help people think more about this and find new ways to build newer applications which are possibly more specific to their use cases. So one thing would be, maybe you want to create this PFP storage network that is tightly connected to Ethereum. But in order to do things on this network, you don't need to pay the Ethereum fee. You just minted the NFTs. They exist there. They're on the mainnet. You don't have to move to an L2. But if you want to adapt the NFT, if you want to adapt the image, if the image has to evolve or do something, it can completely live there and do it in a much cheaper way.
Oh, that's great. That's really interesting. That's really cool concepts we could figure out with that. Does anyone have any other questions?
So you mentioned like this centralized part. Is it, like the way I understand it is this is completely separate from Ethereum, like no validator is going to run this network, but it's just like a centralized point that can update the code and ensures the computation is correct and everything like that. Is this how it's supposed to work, and is this what Shadow does, and why you said it's so centralized?
So yes, Shadow is very centralized because they create your own universe within their system. And let's say that I want to track something related to Uniswap. I'm going to create that universe for me. And you're also a user of Shadow, so you're going to create a different universe. Because we can both replace code, we're going to have to live in different universes. So then we have to have a different view of what's going on Uniswap, or we're just tracking different things. This is what's happening with Shadow, but I think there's a large possibility of creating a shared state between this type of functionality, between doppelgangers, because then we would still have things, Lego pieces. We still have modularity and composability within them. Does this answer your question?
Kind of, yes. So would this be similar to what the graph does?
I think Shadow specifically is a very good competitor to the graph.
Okay.
Yeah.
Okay, thank you.
Anyone else?
So how easy it is to synchronize the main EVM chain with the Doppelganger network? The Doppelganger network with the main EVM chain?
Okay, this is an interesting question because you can do it in multiple ways. You can try to create your own node and replicate all of the transactions since inception, or you can do it like on demand, depending on how you want to change the rules. Since, for example, you make code changes and your transactions will use more gas, you also need to change that rule, because otherwise your transaction or your Doppelganger will fail. So you're changing that. Okay. So now the Ether that is part of the user's wallet is different in your network than the original network. Okay, so maybe you can't do it since inception, or you don't care about that part. And you can do it on demand. So when it happens, you just take the state from Ethereum and use it then.
Okay, so basically you have to plug into the main mempool of Ethereum and then listen to specific transactions for certain apps.
Yes, that's right. You do need an Ethereum URL, RPC URL, to still read the data from Ethereum and to replicate what happens there on your network. So it's in a kind of way, it's Ethereum and Bitcoin and lots of other networks are so closed that we finally start to think like, okay, this is a very closed universe. Whatever happens here only exists here, and we cannot take information out of the outside except with the Oracle concept. In this case, I can connect myself and actually embed a different network within my network, and I have complete access over the data there for basically free.
Thank you.
We have time just for one more question. Oh, no, I thought you wanted to. Is that everything? Yeah? Well done. That was an amazing, really interesting talk.